This is an example of a circuit with a single capacitor element in it. It's seen here that the switch closes when the time is equal to 0. So when the time is before 0, this circuit will be present. So the general form for any element, in this case we're solving for VC of t, for t greater than 0, and it will be the final plus the initial minus the final times e to the minus t0 over tau. For a capacitor, the tau is equal to the capacitor times RTH. So since we have a little bit more complicated circuit connected to the capacitor at time equals 0, this circuitry here, it's going to be easier to find the Thevenin of this. To find the initial value will be where we will start. So looking at finding the first initial value. So that will be at t equals 0 plus. To find t equals 0 plus, which is the time right instantaneously after it switches, you need to find at the time before, where it sat at this position with it, in this case it's open, for a really long time. Redrawing that circuit would be with this open here. So to find the Thevenin, since there is only an independent source here, this will be our A spot and this would be the B spot. And so with only independent sources in there, it's just remove the independent source where IS will become an open, and the pathway will be through R3. At this point it begins to split, so it will be R2 in parallel with R1, and then they combine back to B. So RTH is going to be for this time at this circuit will be R3 plus R1 in parallel with R2. Now VTH is going to be when there's no connections here, so C is open, and the voltage difference between this point and this point will be VTH. So with this open, there's no current flow here. And then to find the voltage across this point, which is going to be the same since there's no voltage drop, this is all one node. And different techniques could be used here. You could do node voltage. You can just look and observe that it's a current divider, and find the current in either resistor and take the current times the resistance. You could combine these two into a parallel form, which will leave just one resistor, and then the current going through the combination of both these in parallel will be the voltage across it. So any of those will end up giving you the same value, and that value will be IS R1 in parallel with R2. So now, because the circuit has been sitting in this position for a really long time, we're going to have the capacitor will be open. Again, it's open because of the properties of the capacitor. We have the voltage VC of t is equal to di, which is the current flow through there. If there's no change over time, this quantity becomes 0, and when you have, I have this backward. So the current flow through the capacitor, IC of t, is equal to the derivative of VC of t over dt with no change in time. This becomes 0, and it looks like an open in between here. So with that as an open, VC of t for this case will then, again, no current flow here, so it will be IS R1 in parallel with R2. So this is the value at 0 minus. At 0 plus, so at 0 minus, the value was IS R1 in parallel with R2. So now at t equals 0 plus, this becomes a short. With this as a short, there's going to be no current flow here and no current flow here now. The capacitor will act as a voltage source now, because that's the value of what we have right before it. That voltage cannot change instantaneously. So this will now be a voltage source with the value that it had right before it switched. So that has to remain constant. So the voltage is what we're trying to find here. So the voltage across this, since it can't change instantaneously, will be exactly the same. So this will be my initial value, IS R1 in parallel with R2. So the next step would be to find at time goes to infinity, which means it sits at the final value for a really long time. This would be the final circuit. With it sitting here for a really long time, there again will be no change with time. So this then becomes an open. So at time goes to infinity, this becomes an open. And then to find the voltage then between here and here, there's no current flow through here because it's open. So the voltage across this is going to just be 0. In the final position, to find the equivalent RTH for this circuit, it will be, this will be A, this will be B, and you can see here that the pathway then from here around here, this becomes an open to find the equivalent resistance, and I just have the RTH is R3. So the final equations, writing out VC of t, again t greater than 0, is equal to the final value, which was 0, plus the initial, which was IS R1 in parallel with R2, minus the final, which is 0, e to the minus t over tau, which was RTH times C. So this is our final equation for the capacitor.